Recently I was pointed to a fun little project by a guy called Rue Mohr who showed that it was possible to produce sound out of a serial port. And I like projects like this because it doesn't really need very much stuff. In fact, just a small serial port adapter, which cost me about £3, and one resistor and one capacitor. Let's give it a go. Okay, so first things first, let's get the serial adapter, which I've set to 3.3 volts, and plug it into the breadboard. And we'll attach the scope with the ground and the signal onto the transmit data. There you go. So now you can see that the signal level is held at a constant 3.3 volts-ish. So if we flip to the CLI for a moment. Okay, so we'll get the terminal emulator started. So I'm using Picocom here, that works quite well on the Mac. I've just set it to 115K2 and I've set the local echo on so that I can show you a few things here. So if I start pressing keys, I'll do a capital A here. You can see the capital letter A in ASCII is 65. So you can see on the waveform, on the very left, you've got a low as the first bit. That's the start bit, which is always low. Then you've got a high, that's the least significant bit. So 65 is made up of a 1 and a 64. So that peak there is the 1. And then you've got low, 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 till you get to the 64, which is high again. And then the 127 is low. And then it peaks back up to the high level there. The stop bit is a high, and it remains high because we're not sending any more data at the moment. If I progress through the letters, so that's an A. If I press a B, you'll see the 1 bit has gone off, the 2 bit has come up. If I do a C, they'll both be set. A D, then the 4 bit will be on, and the 1 and the 2 will go away, so on, so forth. So the next thing I want to show is if I send a continuous stream of zeros to this. I've set my send program to just directly output the file. So if I do /dev/0, I can even zoom this out a little bit. So now we just have the stop bit, because the start bit's always 0, all our 8 data bits are 0, but the stop bit is always a high. So we have just the stop bit coming by every 10th bit. So that gives us a frequency of 11.5 kilohertz. Okay, so the next step is to put in our low pass filter. So we take our resistor, we take that from the transmit data line here and feed that into another row on the breadboard. Then we take our capacitor, we take that between ground and that new row. Right, and you'll notice if I start typing in on my serial port now, the waveform's not quite as clean, it's a little bit squiffy, and that's because of the low pass filter there. And in fact, if I move my probe from the sort of inside of that filter to the outside of it, right, and start pressing keys, well, now you get a very different looking waveform altogether. It's filtered off all the high frequency transitions on those square waves, and it's given you a much steadier waveform. Now I have a file that I prepared earlier which just contains a frequency sweep. So if I send that out to the appliance, you can see we start getting a load of noise on that, and if I zoom that out, that's starting to look quite a lot like audio. So let's try that again. There you go. You can see it's going closer and closer together as it sweeps up the frequency. Now, there's a couple of problems with this. So if I run that again, you can see the peak to peak is somewhere around the 2 volt mark, but also it's biased, it's way up off the 0. So that's not going to be too healthy to plug that into anything that's expecting 1 volt audio. So let's add a few more components to our setup. First things first, let's add a potentiometer here. That will be splitting the voltage between what's coming out and ground. So if I plumb the other end of that to ground and move my scope over a couple of pins. Now if I send that file again, see that I can now control that with the potentiometer. And if I send my file again, yeah, that's nicely under 1 volt now, peak to peak. But it's still biased way off the 0 there, so what I'll do is I will take that output and I will feed it through a capacitor here. And that should, he says, that should remove the DC bias. So if I now send a steady tone, okay, so we can see we got a nice 900 millivolts, 0.9 of a volt peak to peak, nice and steady. Like the look of that. So what we can do now is attach my little audio connector between that and ground, and we should bump that out of the way. Should be able to attach this to our audio input and see what we can hear. So let's try the sweep again. To give you a taste for the audio quality, I decided to do this section of the video through the serial port. I can't use Rue's audio file because I don't have permission from my Note computer, but I do have this. So in summary, I could probably tinker with the conversion process a bit more and make it sound a little bit better, but considering that this was a couple of quid's worth of parts that I already had lying around, I'm quite happy with the output of that. See you next time.